Hi guys, today we're working on limits involving absolute value. There are multiple concepts that we need to understand and just quick review before we go into solving limits and finding limits of absolute value functions. Um, I will revise them as we go through the first example. I think I'll be able to cover them all in first one. Okay, so just think about what the absolute value function is. I'm going to get my handy dandy graphing calculator here. So the absolute value function is, I'm just going to graph it for you. So here is the parent function. So when you graph, is actually two linear functions together, one with the negative slope and the other one with the positive slope. Notice that they change each linear function here. It changes direction right there at the vertex. Okay? And then the axis of symmetry is right there in the middle. So this is a reflection of that. A lot of things that you already know, but we're just revising. So when we're talking about two separate functions, you will know what I'm talking about. So just because I have a different function right here, I'll go ahead and do that. So plug in that function, 1 plus 9x, just so we will see what it looks like. Voila. So notice that the vertex right there is that point right here. It's going to be kind of a little decimal, and yuck, how do I find that? Well, that's the first thing we're going to do when we have an absolute value function. So we will find the vertex of that function. So I have 1 plus 9x, and just know if you set it equal to 0, and then you minus 1 from both sides, divide by 9, then you have negative 1 over 9. That's your vertex. Or that's where your vertex is. But this is not important. What's important is this is the equation of the axis of symmetry. That's the point, that's the spot where your function changes direction from the negative slope to the positive slope. Okay? And that leads us into the piecewise function. When we covered piecewise functions, we talked a little bit about if I have two functions, I will use this function under these conditions, and I will use this function under these conditions. And in this question, in all the limits involving absolute value, you will have to write out your conditions, when to use what. So, and that's what we're going to do. So I will write out the piecewise function for this scenario right here. So I have my f of x. I have two functions, one with the positive slope and one with the negative slope. So 1 plus 9x, and the other one is the negative version of that same function, so negative 1 plus 9x. Under what conditions do I use this or that one? Well, these functions, two linear functions, they change direction right there at the axis of symmetry. So when x blank, negative 1 over 9, x blank, negative 1 over 9. Okay, let's go back to my calculator. So I'll go ahead and graph so you know what I'm talking about. So 1 plus 9x, and that one will graph in red, okay? So when you graph that function, that is the positive leg of that absolute value function. So, and I will definitely use this one when x is greater than negative 1 over 9. So greater than negative 1 over 9. And the other one just leaves me with the less than. But since we're here, I'll go ahead and test it out. So negative 1 plus 9x. So that's the absolute value function, and that is the one with the negative in front. Oh, so it's the negative of that function. That's what represents that part of the absolute value function that I'm using. So bring it all together. When am I going to use what? So in this case, we're trying to calculate the limit as x approaches 5 from the right. That's what that plus sign is telling you. So when you think about 5, think about the number line. So 5 is definitely greater than negative 1 over 9. So because 5 is greater than negative 1 over 9, I will use this function. So I'll write it out so you don't forget. Since 5 is greater than negative 1 over 9, then use 1 plus 9x. Okay? And now you're at the point that you know what function to use and what to do with the direct substitution. So 1 plus 9x is 5. So 45, 46. So the limit as x approaches 5 from the right of this absolute value function equals 46. All right. So now you're like, whoa, 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 rational functions on top of the absolute value. That's not working out for me. Hang in there, because as soon as you break this down and then you choose the right function to use under your piecewise function, everything will be okay. So first thing you need to do, you need to find the axis of symmetry, or when your absolute value function changes direction. So x plus 3 equals 0. So x will change direction right there when x is negative 3. Okay, so this is the AOS, the axis of symmetry. All right. So now I will write my piecewise function just for this part for now, and then we bring it all together, okay? So the piecewise function for just this portion, I have x plus 3 under those conditions and negative x plus 3 under those conditions. I know the absolute value function changes direction right there at negative 3. Okay, so positive slope right there when it's greater than negative 3, and negative slope when x is less than negative 3. Okay, so now I will write out the piecewise function for this whole thing right here, for this rational function. So f of x of this whole thing. So I have x plus 3 over x plus 8 only when x is greater than negative 3. And I will use x plus 3 over, just kidding, negative x plus 3 over x plus 8 under the condition of x being less than negative 3. Okay, so now when I look at this, negative 3 approaching from the left, well, they're both negative 3. That's why I didn't put the equal sign there. Okay, so you have to think about, since it's approaching from the left, approaching from the left, approaching from the left. Okay, so you have to make that decision. Is the left over here or is the left over here? Approaching from the left is definitely less than negative 3. So I will use this one because it's approaching from the left. So let's write it out. Since negative 3 approaching from the left is less than negative 3, I should write it all out, but you know what that means. Negative 3, then use negative x plus 3 over x plus 8. Now you go ahead and you plug in negative 3. So now you're ready to do the direct substitution. So negative 3 plus 3 over negative 3 plus 8. Okay. So it's 0 right there. So 0 divided by anything is just 0. Sometimes you're going to get a different number. But now you know how to set this whole thing up. All right, I have a whole more different examples. Number 3 is kind of easy, but I will break it down to you why this is easy. Because I know when you look at that square and the absolute value, nothing makes sense to you anymore. But let's think about this. So when you're squaring something, whatever that is, it's going to end up being a positive value. So since this squared and absolute value is always positive, then we're going to use this to our advantage. So when you go ahead and you substitute that, so I already had the x plus 6 squared over. Since this is always going to be positive, I can rest assured that this is true. So I don't have the negative option and the positive option. This is always going to be positive. So you look at me and you go, well, wait a minute. Why can't I just simplify this down to 1? Well, you actually can. So, and at this point, isn't that easy to find the limit as x approaches negative 6 from the right of 1? And you know from the limit laws that when you're finding the limit of a constant, the answer is the constant. So when you're evaluating this, you did all this work just to come up with 1. Okay, but if you're capable of simplifying this whole thing down to 1, that's awesome because that's all you need to do. All right, so example 4, we have to find the limit as x approaches negative 2 from the right. Again, I will set it up so the axis of symmetry right here. So AOS is when x equals negative 2. All right, so I will write out the restriction over just the absolute value function. So I have x plus 2 and negative x plus 2 when x is greater than negative 2 and when x is less than negative 2. Okay, now we're getting somewhere. I'll go ahead and write out the piecewise function for the whole rational function right here. So I have x plus 2 over x plus 2 when x is greater than negative 2. And I also have x plus 2 over negative x plus 2 under the condition that x being less than negative 2. And at this point, you're like, yeah. This I can simplify down to positive 1. Okay? Because I would simplify my rational function right there just by simplifying that down to 1. Not 0, not nothing, but 1. And here, this simplifies down with this. I only have the negative left over. So this, I simplified that down to negative 1. Okay? So now, 1 when x is greater than negative 2, and I have negative 1 when x is less than negative 2. Voila. So here we go. Since my limit is x approaching negative 2 from the right, so from the right, it goes that way. Okay? So x is greater than negative 2, so I will have to choose that one. So I will write it out for you. Since negative 2 approaching from the right is greater than negative 2, so we're using this condition right here. So use positive 1. I like when it's simplified down to that. Okay, so therefore this limit equals just positive 1. Okay, so x is a symmetry, x equals negative 8. So set up your restrictions. So x plus 8, so the restrictions will be x plus 8 and negative x plus 8 only if, so you use x plus 8 only if x is greater than -8, and you will use -x plus 8 when x is less than -8. Okay, so we will write out the piecewise function right here for the rational function that we have there. So x plus 6, x plus 8, with the positive x plus 8 in the denominator, as long as x is greater than -8, and x plus 6, x plus 8, under the condition of, oh, I'm not done, negative x plus 8, under the condition of x being less than -8. Okay, simplify what I can here because you don't get a cookie for doing the hard way. Simplify what you can before anything else. So here you only have x plus 6 under these conditions, and here you have negative x plus 6 under these conditions. Okay, so going back to the question, we have to find the limit as x approaches -8. Oh, hold on. It doesn't give me one side or the other side. So that means this is a two-sided limit that I have to find. When you're finding a two-sided limit, the limit only exists if they agree. If the limit approaching from the left and the limit approaching from the right are the same. So, and that's what we're going to have to do. So I will find the limit as x approaches -8 from the left, and I will find the limit as x approaches -8 from the right. So here we go. So which one of these do I choose when I'm calculating the limit as x approaches -8 from the left? So from the left is this one. So I have to use this one. So negative x plus 6. And then we will evaluate. Now approaching from the right, I have to use this one. So x plus 6. Okay, so now we're ready to do direct substitution. So negative 8, substitute that for x, plus 6. Here I have -2. Two negatives make a positive. Voila, 2. And again, the limit, the two-sided limit only exists if these two limits are the same. Okay? So I will plug in -8 for x. Oh man. Okay. So that's a no-go for me. The limit as x approaches -8 from the left is different than the limit as x approaches -8 from the right. So since they do not agree, the limit here for this example 5 does not exist because they do not agree. So a lot of information and a lot of background concepts that we've been working on. 2 more just because. You knew we were going to get one that we had to factor. It was just like, yeah, I just don't know when this is going to happen. So before I do anything, when I look at this, I see x plus 1, x plus 3. If you're still struggling how to factor, you need to do some homework off to the side to get better at factoring, because factoring is kind of important. So here we go. X is a symmetry. X is -3. Okay? So set up x plus 3, set up your restrictions right there. So you use x plus 3 when x blank -3, and negative x plus 3 when x blank -3. You already know this. I can't even make it a mysterious mystery. Okay, so when x is greater than -3, you use the positive. When x is less than -3, you use the negative. All right. We will go ahead and write the restrictions, because we have to, of this rational function right here. Okay, so x plus 1, x plus 3 over x plus 3 as long as x is greater than negative 3. And then x plus 1, x plus 3 over negative x plus 3 when x is less than negative 3. You already know we're going to simplify the rational expression right there to make it simple. So simplify right there. I have x plus 1 left over. Simplify right there. I have negative x plus 1 left over. And these are the conditions to each one. Okay, so again, another two-sided limit. So that means I need to find the limit as x approaches negative 3 from the left, and limit as x approaches negative 3 from the right. So approaching from the left, I use that one. And approaching from the right, I will use x plus 1. Okay, direct substitution here. So negative 3 plus 1. That gives me 2. Because here I have negative 2, negative, negative, make a positive. So positive 2 right there. And here, negative 3 plus 1, that is negative 2. And a two-sided limit only exists if the one approaching from the left and the one approaching from the right are the same. They need to agree. Otherwise, this limit does not exist. This limit does not exist. Does not exist. All right, last one. So when I look at this, I see the factors. I see x minus 4 squared. Okay? So from example, was it 5 or was it 4? One that we just did. So I know the absolute value of x minus 4 squared will always be positive. Is always positive. So therefore, I can just simplify this one down to x minus 4 squared because I know this guy is always going to be positive. So there's no reason for me to open that one is positive, one is negative. Don't worry about it because this is always positive. So when you simplify that, that equals down to 1. And then you're simply just finding the limit as x approaches 4 of 1. It doesn't matter from the left or from the right, they're going to be the same. So therefore, the limit of a constant is the constant. So voila. I hope this helps a lot. I'll see you next time.